Alright, I've started streaming, guys. I'm live streaming now. The link again. No, you can still use that same link will work. The same live, yeah. To make things easier. Don't stop, please. This will be, you'll be very scared when the plane is ascending and descending. I think it's a phobia. How many times have you traveled on flights? So maybe if you do that like 6 or 10 times, you get used to it. My first time, so I was afraid. Okay, so we have a, let me add another section. This one is for the book. Amazing maths. Okay, guys. So I think we stopped at what problem the other time? I think that was Belfast. Problem 9, 12, 14, 15, 16. Okay, I think we're doing that statistic, right? That graph. So I think there's another question there, question 19. So solve at question 18. Are you guys seeing the, all right. So if you guys are ready, let me know, please. the median and the mode, the mean. Okay, so let's look at question 19. It says Antonio has a shop near the beach. He makes a tally of the number of ice cream he sells on Friday. Work out the number of ice cream he sells on Friday. So we can actually use the tally. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you know each of them is 5, right? So 9 times 5 is 45. 45 plus 3, that's 48. So the answer to this is 48. So I'm just going to pick a pen and write it there. So 48 is the total number. Okay. The next one, 15 of the ice cream sales on Friday have vanilla. Work out the fraction of ice cream sales on Friday that are vanilla. Give your answer in the simplest form. So how do we do this? 15 of the ice cream it sells on Friday are vanilla. Work out the fraction of ice cream it sells on Friday that are vanilla. So which means we must find those amounts that will exactly give us 15, right? And that's just 3 out of the tally, am I correct? So that means the fraction is going to be 15 over 48, isn't it? Which in the lowest term will be both are divisible by 3. So that will be 5 over 16. Am I correct? Yeah. 16 times 3 is 48. Because 6 times 3 is 18. So that would be 5 over 16. The next question. So here we have a bar chart. Maria owns a restaurant with 30 tables. One day she records the number of customers at each table at 7 p.m. The bar chart shows the results. So that's the bar chart showing the number of tables to the number of customers at each table. So we're asked to write down the mode. Now you need to be careful here because the two axes are using the same like the same amount, the same type of quantity, number. So you can make mistake there if care is not taken. So if they ask us to write down the mode, what does it signify? So I think the bar chart will give us a clue, isn't it? There are some bar chart that also goes like this. I hope you know that. But we are usually used to the ones that goes up. So since this one is going this way, and you know that the frequency of the bar chart denotes the height of the bar. So the one with the highest height is at 4, isn't it? So the mode is what? 4, and that 4 represents what? The number of customers at each table. So put your answer here as 4. Find the range. Range is the highest minus the lowest. The highest value minus the lowest value. So the highest value we have here is what, please? Here we have 6 customers, isn't it? And the lowest is, but now here we need to be careful now, right? So it can't be, that's why I said this question is a bit tricky, so you don't fall into the trap. So we can write the number of customers at each table for as the mode. Because that one is just representing the height of each graph. Like it's just where the height. So for example, when you have 4 customers, the height is what? I think 9, isn't it? So we can't say the mode is 9. The mode refers to the whatever thing that has the highest amount of number. For instance, now, if we are counting the numbers of boys and girls in a class, so the number, if the number of boys is higher than the number of girls, then the boys have the, like, they are in the modal group, isn't it? So in this sense now, the mode is 4. The mode is not 9. 9 is just the value of the mode. So now if they ask us to find the range is the highest value. So we can't say the range is highest number of customers minus lowest number of customers. Do you get it now? So we have to actually look at the highest value. The highest value there is 9, isn't it? Which corresponds to the one that has the highest mode, right? Then the lowest value is what? 2. So the range is going to be what? 9 minus 2, which is 7. All right. So let's move to the next question. Calculate the mean. Now, since this one has frequency, okay, remember the formula for mean, x bar. You can find it using the mathematical formula, is equals to, this symbol means summation. It means you sum up the frequency times the score. The score is usually represented as x. Then you divide it by what? The cumulative frequency, summation of what? F. So usually it is always good to use a table, draw a table to do your calculation so that there won't be any mistake. So if I'm going to use a table, I'll first start with the scores. But now you now need to know what the scores represent. Then I'll now take what? The frequency. It is easy for me to understand because I know that the frequency represents the height of the bar. So the scores here are the number of customers at each table. So we have 1, 2, 3, we have 4. Let's turn this one a bit. Then we have 5 and 6. Okay, that's the number of customers. All right. Now the frequency corresponds to the height. So when the number of customers is 1, the height is 2. That's the number of tables. The height is 2. Sorry, when the score is 2, the height is 7. So put it there. When the height is 3, when the score is 3, the height is 3. So put it there too. When the score is 4, the height is 9. It's because it's between 10 and 8. When the score is 5, the height is 4. So we also record it there. And then when the height is score is 6, the height is 5. Alright, so it's always good to organize your data in form of tables. So the next we'll find the summation, the product of the frequency times the score. So let's do that. 1 times 2 gives you 2. 2 times 7 gives you 14. Okay. 3 times 3 gives you 9, right? 4 times 9 gives you 36. 5 times 4 gives you 20. And 6 times 5 gives you 30. So let's do the submission. So let's start with the frequency. So if you add everything together, 2, I think you should get 30, isn't it? But let's confirm. So 2 plus 7 is 9. 9 plus 3 is 12. 12 plus 9 is 21. 21 plus 9 is 30. So that's correct. So let's get summation of f of x. 2 plus 14, 16. 16 plus 9, 25. 25 plus 36, that's 61, right? Am I correct? 61 plus 20, 81. 81 plus 30, 111. Sorry, 81 plus 81, 11, yeah. So that's 1, 1, 1. Okay. So we have all that we need to find the mean for this data. So let's find the mean. So the mean is going to be 1, 1, 1. Of course, it's going to give us a decimal divided by 30. So when you do that, so you have a calculator here. So let's use a calculator to get that. So that will give you 1, 1, 1. 1, 1, 0 divided by 30. That's 3.666666666. So we just take it to 2 decimal place. All right. Since we are not giving any specification of where to approximate it to. So 3.67. That's the mean for the data. So let's move to the next question. On the same day, she also recorded the number of customers at each table at 1 p.m. The results are shown in the table. So here you see number of customers at each table and the number of tables. So they're asking us to write down 2 comments comparing the result from 7 p.m. with the result from 1 p.m. Usually anytime they're asking you to compare, they're asking you to compare average. And when we talk of average, there are various kinds of average. Because average is a measure of something at the middle. Do you understand? Mean is a kind of average because it helps you to find something at the middle. Am I correct? Median is also a kind of average. I hope you know that. Because it also helps you to find position of. Then mode. Is mode a kind of average? So mode is actually not a kind of average, but it's just trying to find. But it's also a kind of mode means the most occurring. You get it now? It's just more like something that is occurring more. You get it now? But in statistics, they always classify it as all measurements of central tendency. Okay, there might be a reason for that, but I think it's more intuitive to see mean and median as measurement of average. Then another measurement in statistics, whenever you have to compare, you have to compare average or has to compare deviation or spread. Now there are various measurements of spread. The first one that is very popular, who can tell us, tells you how spread some values are. It's called range. So anytime you're talking about range, you want to measure how much the spread gives you an idea of spread. Also, we talk about variation. Okay. Then we also talk about there are other types of spread. There are so many. Like we talk about the quartile. Quarter is like a quarter of a quarter. But if you want to divide your what do you call it now, your data and categorize it into those data that fall into the first quartile, second quartile. Quartile just means a quarter of everything you have. So let's say in the class of 10 students, you have the score of those students. Okay, so you can now divide the performance of the student in the class based on quartile. So what simply means that you have the first quartile. First quartile simply means 1/4 of the total number of participants for that test. Second quarter means 2/4 of the total number of participants in that. I'm trying to teach statistics, but just giving a brief summary of statistics in this Cambridge topic, this course we are doing. Then third quarter is 3/4 of the total number of. The total number is usually called the what? The total frequency. Do you get it now? Because in a class now, you can have some of them have the same score. So let's say in a class of 10 people, you have 2 people that have the same score. So which means if you draw your graph, if you draw your frequency table, like you group the data. So let's say in that class of 10 students, there's a student that scored 20. Let's say 20 is the highest mark. There's some student that scored 10, and there are some students that score 5, and there's a student that scores 0. So how many students score 0? So when you put the score 0, how many? 20, how many? 40, just like that. So when you want to get the quartile, usually there are two popular quartiles that we talk about. We talk about the upper and the lower quartile. The upper quartile, let me start with the upper quartile. The upper quartile, you would have think the upper quartile should be 4/4. 4/4 is the same thing as 1, right? So the upper quartile is not 4/4 of the total. It's 3/4. 3/4. If you convert it to percentage, that would be what? 75%. There's another measurement of spread we call percentile. Percentile just means percentage. So if I want to convert from quartile to percentage, I will just multiply by 100. So 3/4 or the third quartile is also known as the upper quartile, while the lowest quartile is 1/4. So these are measurement of what? Spread. They are all measurement of spread. So I've talked about range, I've talked about quartile, I've talked about percentile. Percentile just means percentage. Everything is going to be 1/100. So who can tell me what decile will be? Decile. No, it's going to be 1/10, isn't it? Or decimals are 10 symbols. We need 10 symbols for decimal. Okay, so that is that. Then we have the standard deviation. Deviation is just more like range, but the reason why deviation is different from range is because the difference you are considering is from the mean. You know, mean is a measure of average, isn't it? So for instance, in a class, when you say mean now, what does mean gives? What does mean tells you? It just gives you a kind of the strength of the whole class. So if you have a class and their performance is on the average, let's say out of the total of 20, you have, let's say, 10 points, maybe 4. So it gives you an idea of the strength of the class, isn't it? But it doesn't give you, it only gives you an idea of the strength of the class on the average, not, it doesn't tell you about the individual students in the class. Am I correct? Because there are some students that might actually score like 20. There are some students that might actually score below 20. So spread or deviation, sorry now, is now telling you, it gives you, so if the deviation is very high, for instance now, let's say from the average, which is let's say 10, you now see a student that scored 20. So 10 minus 20, that gives you 10, right? It gives you how far, how minus 10 or 10, since we are looking at the highest, like the highest score from the mean score. But usually, when we talk about deviation, we are not really considering whether it's going to be minus or plus. We are looking at how far it is from the average. So if I say 10 minus 20, it's still the same thing as well, 20 minus 10, because I just want to know how far. So the student could be doing well. Of course, student that have 20 has performed very well, right? Because he or she has scored the highest mark. If I also say 0 minus 10, of course, that student is also performing very, very woefully, but he doesn't get anything. But on the other side of the line. But the most important thing is that we know how far they are from the average. Okay, so when you want to find what they call it, the standard deviation. Deviation is just to find the difference between the mean and the score. But standard deviation now means you now have to take account of all the deviation in the class. How many times do they occur? So let's see how the standard deviation. So for standard deviation, SD, so this is how you get the formula. All these are measurement of spread. So it's usually given by the mean is S bar, hope you know that. So mean is S bar minus X. So what does this mean? This means deviation. So I'll call it D. So D is given by X bar minus X. See that now? Okay. So when they say mean deviation too is a different kind of measurement. So what does mean deviation mean? From mean means summation of all the scores divided by the total number. So mean deviation means what? No. If mean means total score, right, in a class, divided by the total number. Mean is the measurement of average, like to know the median of a score. So if you have deviation, each of the deviation, all the individual has their own deviation, how far they are from the average of the score. So the mean deviation will now be what? To sum all the deviation. Am I correct? So you have to add all the deviation in the class and divide it by the total number. So mean deviation MD will be summation of deviation divided by the total number. Do you get it now? Summation of the whole of this. X bar minus what? Minus X divided by what? Total number. I hope you know that sign that looks like it needs to add up. Okay, so that is mean derivation. It actually makes sense because mean, anything means finding center of a score. That's what it means. Okay, now this mean derivation is when you don't have, like, all the derivations are not repeating each other, that there is not repeated. What if they are repeated? Like some of them occur 2 times, 3 times, then you have to multiply the frequency. So that means if you have the one for frequency, you have to put F in front. Do you understand? It's just like mean too. If there is no frequency to mean will just be summation of X divided by what? Total number N. Am I correct? That's when there is no frequency. But once there is frequency, like once a score repeats any number of times, then it will be summation F of X divided by summation F. So if it's also repeats here, this N will become what? Summation F. So I'm going to correct this. Summation F. Okay? Now, when they say standard deviation, now the reason why it's called standard deviation is that the deviation, you take the square. So you first take the square of this deviation. That's this square. If it occur more than one time, you have to multiply by frequency. So you have frequency in front. You see these formulas actually, they make sense from the definition of mean and median and spread, what the spread means. Then you add them all up together and then you divide it by, you can tell us what's going to be at the denominator. That will be summation of what? F, isn't it? So this is what we call standard deviation. So it gives you, you can see that it's looking like a mean something. It's also looking like a spread, but it's actually a measurement of spread. So it gives you an idea of the way the scores in the class are away from the middle or the average score. So all these measurements, they are very, very important in statistics. Statistics is very, very important because there are so many things you are learning now. Like some of this AI, what they call it, the chat GPT and all that, they make use of some of all these stuffs in order to make some decisions. Okay, so mathematics has a lot of applications that you don't know of. Okay, so it's not just a theoretical subject, it's a very, very practical subject. So in summary, whenever you are asked to compare two uh, data in statistics, they're asking you to compare their average or their spread. So if you are to answer this question, you can first of all try to find the average of the two things you are comparing. So the one that has a higher average, what do you say? You can now start making your comment. So if there are two classes and they did call an extended math, one class has an average of, out of a total of 100%, one class has an average of 50, another class has an average of 80. Which class do you think performed very well? That's the comment. The one that has the higher, isn't it? Okay. But does that mean that everybody in that class are very, very good? So you can see the comments now mean that on the average, this other class is doing more than others. Now let's go to spread. What if you find the range and you discover that that class that has 80, their range is, you got the range to be, let's say, 60. I'm just using that as an example. It's not, it might not be a very good example, but just to drive home what I'm trying to explain. And the other class that had, was it 60 I mentioned? One class has 80, the other class has 50. So the other class that had 50, their range is, the range you got is 10. So what can you say about that? In terms of what? So class A had 50% as average. Class B has 80% as average. Class A that has 50% as average have their range to be, what did I say again? 10. Was it 10? I said yes, 10. While class B that has their average to be 80% have their range to be, I think I said 60. So what can you say? First, using their average, we said, okay, class B is performing more than class A. Now, using the range, what can we say? So this thing you have to now look at, you're not looking at, because I asked you that those classes that had 80%, does it mean that automatically everybody in that class, they are very good? It doesn't necessarily mean. It's just telling you that, oh, we have some potential students that are doing very well. Because if you are in a class and more people score higher mark, it increases the average, isn't it? Isn't it? Yeah, it does. But look at the range now. Their range is higher than the class that has 50. So what can you say? Yes. Okay, good. Good. That's a good observation. But for the other class, what can you say? Because when you compare, you have to mention both of them. That's what comparison means. Please give this boy a very big clap. So what it's saying is that even though those classes, class A do not perform as much as class B perform, but they are all of equal strength. Let me use that word. You hear it now? Like if you pick a random person in the class now, and let's say the person score 40, the next person will be scoring something close. Are you getting it, Rodney? something close. So they are not. So in a class now, you see that all of them are at the same level. Let's use that. But the other class that had 80%, the range is very high. So it means if you pick, let's say someone score in that class 100, the next person can be scoring 0. That's just what it means. So which class is more consistent in terms of their performance? Which class do you think is more consistent? Or if we want to say which class is the teacher really did, like he was able to really carry everybody along, and we saw it. You understand what I mean? You can be in a class and the teacher teaches the class and hey, impressive performance, but there are a lot of people who are really, we can use it to evaluate the teacher's work. We can also use it to evaluate the students in the class. Do you get it now? So it can give us an information of the class. For instance, for me, I can say class B has a lot of weak students. It is those students that are very, very intelligent. They are not so much. They are the ones that's actually making the average to be high. Why class A? Even though class A doesn't have some students as strong as class B, all the students in class A, they have equal strength, not so far away from each other. Do you get it now? So this statistics has a lot of interpretation. So now let's apply what we've learned to this question. So write down 2 comments comparing the result from 7 p.m. with the result from 1 p.m. So let's take a look at this. Remember, you have to be careful because both of them are using the same quantity, like number. So because normally number is usually used for frequency, right? But this one now they are using number of tables, number of customer. So you have to know which number is referring to the score and which number is actually referring to the what? Frequency. So let's go. On the same day, she also recorded the number of customers. So this number of customers, is it referring to the score or the frequency? It's a follow-up question from what we did from the previous one. The previous one we did, we know that the number of customers at each table is referring to, let me go up a bit. Oh, we are getting this stuff. Okay, so I think the bar graph, the bar chart makes things clear for us. So we know that the number of customers at each table is the score, not the frequency. Because for every bar chart, the height of the graph, the height of the bar is the frequency. So we know that the number of tables is the frequency. You get it now? Number of customers at each table is the score. Number of tables is the frequency. So we know that for sure. So if we now go there, on the same day, she also recorded the number of customers at each table at 1 p.m. So the number of customers at each table remains the score, isn't it? The number of tables remains what? The frequency. But there is a change of data. The data are not the same. You can see that the number of customers remains the same. 1, 2, 3, 4. So that tells you that's the score, not the frequency. But number of tables has not changed. 18, 13, 5, 4, 0, 0. So write down 2 comments comparing the result of 7 p.m. 7 p.m. was the previous table with that one has bar chart. They even gave us a bar chart with the result from 1 p.m. So what can we say? So we need to do some average. So you cannot see anything until you find average for the two. Am I correct? That's the essence of all what I've been talking about. So let's do the average for this new table. It is the average that will now help us to know. Don't just look at the table and make your decision, because you need to make more informed decision by actually getting the average and getting the range. So if we find the average, I think It's something we can do. 1 times 8 is 8. Are you getting it? I'm using the formula, but now I'm not writing out the formula. I'm doing it directly. 2 times 13 is 26. So plus 26. Okay. Plus 3 times 5, that's 15, right? Plus 16, right? 4 times 4. And the rest is 0, so we don't need the rest. That we don't need the rest doesn't mean that the total number is going to be, what do you call it? Just count 1, 2, 3, 4, 5. No. So what total number are we going to divide by? That will be the total frequency now. 8 plus 13 plus 5. Am I correct? So 8 plus 13, that's 21. It's still going to be 30. Just that some people now shifted. It's still the same regular customers that are coming, 30 customers, just that some didn't come to some table again. So 8 plus 13, 21. 21 plus 9, 30. So it hasn't changed, right? So adding this together, let's find a new mean. So that will be 8 plus 26, that's 34. 34 plus 15, 49. Am I correct? 49 plus 16. 49 plus 16. 65, not 64. Isn't it? So 65 divided by 30. So let's do the calculation for that. It will be 1 point something. 65 divided by 30. That's 2.1666666. So that would be 2.17. 2.17. I think already you are seeing comparison here. Now, the next thing is let's take the range, Abi. So the range will be, what's the highest? 13, right? 13 minus lowest, 4. Okay, 0. That's 13, right? You are correct. Because 0 is also part of it. So, first comment should be based on average. So, you can tell us the first comments, what the first comments will be. Of course, now you have to look at the situation, because here now, there are customers, number of customers at each table, and then we now have tables. So you are going to, the example I gave you was in the context of student performance. This one is in a different context. So your comment should be based on the context, but you are still going to use the same idea. So who can give us the first comment? You might want to go read it again. Maria owns a restaurant with 30 tables. One day, she records the number of customers at each table at 7 p.m. So look at the context. The bar chart shows, so which means she has tables, customers. But some customers visited some tables, some do not. Isn't it? We know that the customers are the score. Even though it will have, to us, it will have looked like, oh, let the customer should have been the frequency now. But in this way they represented this bar chart, the customers are the score. But the tables are what? The frequency. It doesn't make sense intuitively because you're like, oh, we have tables here, customers are coming. So how many customers you have to be the frequency? But in this context, the customers are the score, while the tables is the frequency. So now the mean for the first data at 7 p.m. Of course, you can see that mean is higher than the mean at 1 p.m. So what can you say about that? Mm-hmm. 7 p.m. Mm. So in this context now, you have to use uh, is it scores you have to. I'm just using score to show that the number of because they are using number for both of them. So that's why I'm using score and frequency so that you don't confuse number or number of customer, number of tables. It's almost meaning number. So here, when we talk about performance of a student in a class of 10 students, each of the students have their name, A, B, C, whatever. They have their performance, isn't it? Students score 0, students score 20, blah, blah, blah. How many times they have all those stuff. So the in that sense now, we say score. In this sense, we are not saying score. We are only using score so that we differentiate, we will not get the confusion from the question because they are using number. So the score you are referring to now, you are correct, but I'm trying to rephrase it based on the context. So you say the number of customers on the average that maybe come to a particular table is more compared to the number of customers that comes to a particular table at 1 p.m. Obviously, that's what we can see from the average. Did we do range for the other one? The range is 7. But the range for 7 p.m. is smaller than the range for 1 p.m. So that will be your second comment. So can tell us what the second comment means based on this context. So let me write the first comment while you are thinking about the second. So write down 2 comments comparing the result from 7 p.m. result from 1 p.m. So of course, from this, we see that so from this we can say there are more customers on the average at a particular table at 7 p.m. than at 1 p.m. So that's what I'm going to write here. Fortunately, I don't know how I'm going to write it. I'll have type, but let me see if I can just use. I want to type it. Okay, so let me type this. There are more customers. There are more, there are more customers that's there are more customers on the average that came on the average per table. Let's do that one. That came at 7 p.m. than 1 p.m. Do you guys agree with me? Based on the results. So I'll just put it here, please. So give us the next comment. There are more customers on the average party that came at 7 p.m. than 1 p.m. So give us the next comment. Based on this comment. The range of, okay. The number of customers at each table was higher. It's almost like you're almost saying the same thing as first comment. Okay, okay. That means we use more tables at 1 p.m. So we use less table at 1 p.m. than we use at, let me see if that's correct. The average, there are more customers on the average party that came at 7 p.m. than 1 p.m. That one has makes sense because that one average is 3.67. The other one is 3.17. Okay. Remember, the score here is the number of customers. That's why there are more customers. In this sense now, for the range has to do with consistency, please. Consistency. So for me, at 7 p.m., the customers are not consistent. Because even though average is high, mean is high, range is low. Are you getting it now? So I want you guys to be able to interpret it. Yeah. It's not, I think it's coming a little bit. It's like, let me not say it's complicated. You're looking for the right words to use to express. You have the idea in you, but you're looking for the right word. So let me give you guys a context based on what we discussed earlier. You know, for the student in a class, the score is the most important thing that we use as our basis, isn't it? So even if we are talking about range, we are also talking about the scores. Don't forget. When we talk about mean, we are also talking about the scores. Because the mean, we say this mean is higher than this mean, is the scores. And the scores is what we use to measure performance. Oh, this class has higher score than this. But when we talk about range, remember we are talking about how far it is from the what do you call it, the highest minus the lowest. So if a student, if the higher the range is telling the gap between the highest performing student in the class and the lowest performing student in the class. So if the gap is so much, of course it tells you that in that class the consistency is not so much, like the whole class, they are not, their level is not close. Okay, so I'm using this example to give you a perspective so that you will use that perspective in this context. So now, for the range to be smaller, it means that let's forget about whatever the mean is now. Let's get the range clearly. It's not, so for the range to be smaller, it means that even though whether they perform well or not, you discover that their level are close. You get it now? The level is close. So I'm using the context of performance of students score. This context is number of customers. So I think with this little information I've given you guys, or with this perspective, you'll be able to express what you have in mind about comparing the two. Uh, the two. So the second, by 1 p.m., range was higher. 7 p.m., range was lower. So what can we say about the two? Remember, in this context, number of customers, don't forget. For the previous context, previous example I talked about, what was the context? The score in the test. Yeah, that was the context, the score. Okay, that's for, is it for 7 p.m. or 1 p.m.? Yeah, it's lower.
So like if there were 16 people, all the implementation on one day, instead of we spread it out.
Yeah. So I think that's it. So even though there are more customers that that came, at 7 p.m., they are, how do you put it now? The number of tables was not much, isn't it? That's it. The number of tables was not much. All right. So let me type that here. I think I just have to forget. Even though, even though the number of customers, right, that came by 7 p.m. were much, the number of tables was, can we say little, or was not much as compared to those that came by 1 p.m. Was not much as compared to those that came. Okay. Um, Usually, let me see the timetable. Yeah, we started late. Usually start late, so that's the challenge. Let me see. Yeah, it's supposed to be at 11. So I think this is almost 12. So we can call it a not a day. We still have one class by 2:10, which is hard maths. All right. No, we still have another class by 2:10, hard maths by 2:10, 2:10 to 3:30. That will be 3:30. Yeah. Except if let me remove this thing. Hold on, let me remove this thing from